You build a great app. It catches fire overnight. Your traffic spikes 50 times higher than your wildest estimates. And then the servers melt down, plunging your entire platform into darkness. Going viral can bankrupt a business exactly as fast as total obscurity. When Pokémon Go launched in 2016, the massive influx of players trying to catch Pikachu immediately overwhelmed their databases, causing the entire system to crash. We saw the exact same failure cascade at early Twitter. During global events like the World Cup, millions of simultaneous tweets would lock up their single main database, triggering the infamous fail whale error page day after day. This is known as the scalability problem. As technology executive Sriram Gopalan explains in his book Bridge the Gap, the true challenge of software design is surviving the transition from 100 users to 1 million. When a site crashes, the immediate reaction is usually to tell the engineering team to just buy bigger servers. That instinct is a costly mistake. Handling massive growth requires a deliberate architectural choice, not a blank check for hardware. Imagine you own a highly popular pizzeria. It's Saturday night, you have one chef working at top speed, but he can only bake 10 pizzas an hour. Outside, 50 people are waiting in the rain. To fix the bottleneck, you might fire your average chef and pay top dollar for a Michelin star professional. You also buy a massive, futuristic oven to cook faster. In software, this is called vertical scaling. It is the equivalent of taking your application off a small server with 4 gigabytes of RAM and migrating it to an expensive machine with 384 gigabytes. RAM stands for Random Access Memory, which is the short-term memory a computer uses to handle active tasks. Look at the bottom panel of this diagram. It illustrates the fatal flaw of vertical scaling, the physical ceiling. Even the greatest chef in the world can only work so fast. Buying a single, massive server hits a hard physical limit where the costs grow exponentially, but the performance stops improving. Vertical scaling works reliably for an early-stage startup. Eventually, though, it caps your maximum revenue because the hardware simply cannot get any bigger. The alternative is the franchise model. Instead of buying a super oven, you rent the storefront next door, build a second kitchen, and hire a second average chef. This diagram's middle panel maps out horizontal scaling. Instead of buying one massive server, you buy 50 cheap ones. If you need more capacity, you just plug in another cheap server, unlocking infinite growth. But as the top panel of the diagram shows, you now have a new problem. 500 customers cannot yell their orders at 50 different chefs. You have to introduce a load balancer, a system that acts as a host, splitting the incoming traffic and directing orders to chefs based on who is available. A load balancer acts like a traffic cop, quickly waving data packets through to available servers. You might also hear engineers mention an API gateway. An API gateway is a management tool that sits between a client and a collection of back-end services. It acts more like a hotel concierge, stopping to inspect security rules and enforce policies. You use the cop for pure speed and the concierge for control. Horizontal scaling completely removes the physical ceiling on your capacity. The trade-off is that it shifts your engineering burden from buying expensive hardware to managing complex network coordination. A hidden trap can break a horizontal system. Imagine one of your chefs keeps his special pizza dough in his own apron pocket. If a customer orders that specific pizza, they are forced to go to that specific chef. Engineers call this a stateful architecture, and it destroys scalability. If that specific server goes offline, the user's connection drops and their data is trapped because no other server has the information needed to help them. To fix this, the system must become stateless. All the dough is moved into a giant shared walk-in fridge, your database. Now the servers are identical clones. A user can connect to any available node, and that node simply pulls what it needs from the central database. You cannot scale horizontally to millions of users if your application servers are holding on to unique user data. The application layer must be entirely divorced from the data storage layer. Scalability is not an IT problem you can patch after a successful launch. The architecture you choose on day 1 dictates whether your business survives day 100. To prevent a total meltdown, leaders must ask their teams 3 questions. First, are we hitting a vertical limit? Often, companies buy bigger servers simply because they are avoiding the hard work of re-architecting their code for horizontal scale. Second, is our application truly stateless? If your servers are hoarding unique user sessions instead of acting as interchangeable clones, your system will bottleneck. Third, are we using a concierge when we need a cop? If you are routing high-volume traffic through a strict API gateway instead of a fast load balancer, you are intentionally slowing down your own network. The gap between business goals and engineering execution is linguistic. Translating between technical architecture and business outcomes is the ultimate leadership skill. To master these concepts, check out Sriram Gopalan's book, Bridge the Gap, and subscribe for more breakdowns of the systems running our world.